For question number 13, we're going to be looking at the reaction where hydrogen peroxide becomes liquid water and oxygen gas. So this is a reaction that we've seen many times in our lives where if we get cuts or scrapes and we put hydrogen peroxide on it, we see oxygen gas bubbling out. So this is definitely a reaction that we know is spontaneous. So let's do the calculations to show that it is. So delta H is going to be minus 285 for the liquid water. Make sure to check that it's liquid, not the gas value for water. And then, because remember oxygen is in its standard state, oxygen gas, where it doesn't have a heat of formation, we're then going to be looking at the hydrogen peroxide heat of formation. And so this is going to be around minus 196 kilojoules. Okay, for the bond energy, hydrogen peroxide looks like this. Therefore, we're going to be breaking 4 OH bonds, right, because we have 2 of them. We're going to be breaking 2 O single bonded to an O. And then we're going to be forming 4 OH bonds, right, because there's 2 waters. And we're going to be forming 1 O double bond. This is going to give us a value of about minus 203. So let's calculate the change in the gas, moles of gas. So this is going to be plus 1, right? Because there's no gas on the reactant side, only 1 mole of gas on the product side, so 1 minus 0. So we know that work is going to be negative. In doing the calculations, we've already done this many times before, we'll get something around minus 2.5 kilojoules. So this is work done by the system. And also the delta N for the system is going to be, so 2 moles, and this is 3 moles, so it's also going to be plus 1, 3 minus 2. So now let's calculate the delta S. So delta S, we need to look at, for liquid water, it's going to be 69.91. For oxygen gas, it's going to be 205.14, minus negative coefficient for the reactants, 109.6. This is for the H2O2. This is for the O2. This is for the H2O liquid. And so this is going to be around 125.76 joules per Kelvin. And so T delta S is going to be 300 kelvins multiplied by 125.76 joules per Kelvin. And so this is going to equal about 38 kilojoules. Okay, and so now we can calculate the delta G. So delta G is delta H minus T delta S. This is going to equal about minus 196 minus 38 kilojoules is going to be minus 234 kilojoules. So this is a spontaneous reaction, right? Less than 0. The delta G is less than 0 is spontaneous reaction, just like we predicted.